First, I want to thank people for inviting me to talk, and also especially thank Oz for giving up his original concurrency talk that I didn't know was scheduled, but he said, oh, you should go talk on this. So today, we're going to talk about buzzwords in Python and buzzword compliance in Python, because there's so many buzzwords you have to know. And I'm only going to talk about some of them. And what I'm hoping to do is to go through, and I'm going to give you about 3 slides per buzzword. This is going to be enough that you're going to understand what this little topic is about. And it's going to give you a little bit of breadth through all of Python. But it's not going to go through far enough to answer all your questions. It's really about trying to show you an exploration of what's in the whole Python world here. This means that I'd ask that you hold your questions, because otherwise we certainly will go down an infinite number of questions, and I'd like to give the talk and then answer all of your questions. And I'll make myself available for as long as necessary so that I can say, I don't know, as many times as it takes. So let's talk about exploring Python, because it's fun and it's large. And there's really 3 aspects we're going to be looking at here. One is the Python language itself. You know, after you get past print hello world, there are a lot of features in Python that it takes time to learn and get used to. And then there's also a whole bunch of libraries that are kind of like solid building blocks. You know, you can pick them up, you import them, you use them, they mix and match together. And remember, Python is always about trying to make you more productive as a programmer, so that when you've got something unique that you want to do, you can put it up and just go. And finally, there's these big honking spiky frameworks. These are also part of the Python universe. And they're large. I'm going to pick on, for the frameworks, I'm going to pick on web application frameworks. For the libraries and building blocks, I'm going to pick on games and graphics. I could have picked any other group, but this is to try to give you a feeling for how these are available and how they all fit together. So first, let's talk about learning Python. How to get that snake in your head. If you haven't started learning Python, you should. And the very first thing you should get is you should go out and get Arguet's little FAQ on it. And this is going to be a 5 or 6 page document that is the summary of what all of the syntax is, what all of the major modules are. And it's kind of dense to sit down and read, but you'll find that you keep it next to you while you're going through and said, OK, I've just gone through the Python tutorial, and I forgot, how do I declare a class? Oh, you just do it this way. So you get that. At the end of the talk, I'll give you the web address where tomorrow all of the links will be up and available so that you can get all of your notes and things. And I'll post it to the BayPIGgies mailing list. You should also go through the Python tutorial, which is a good way of reading and typing code and kind of getting a feel for how it all works. And then you should move on to actually trying a few things on your own. I'm recommending one piece here called the Python Challenge, which is a website that has little puzzles in Python that you can write in 1 to 10 lines of code that if you just do the right thing, you can figure out the secret message in the web page and get to the next level. And for the first dozen levels or so, it's pretty good. But really, the thing I want you to get from this is that there's a cycle of learning in Python, that you're going to keep going around in this weird circle. You're going to do a bunch of general reading or watching a couple of videos. I heartily recommend the Advanced Python Understanding Python video, or Code Like a Pythonista. There's a lot of good things to just go and read. Make sure you go do some code. You'd be surprised how many people get into this new language, and they just sit and they read libraries all day. And they forget to actually write something, because that's where you cement the knowledge. You can explore all these beautiful colored libraries, especially the standard libraries that come with Python. Python has this batteries included idea of most of the libraries that you're going to need come with it. And it makes a huge document to sort of look through. But the more that you pick up, the more different types of problems you can just solve. So in a lot of ways, Python is often about you have some concept of something that you want to do, and you want to get there with as little effort as possible, leveraging the libraries and tools of other people. And you have to start exploring the tools as well. There's things like PyChecker, which is a little lint problem a lint-like program, that will save you some time. There's unit test frameworks built in. There's quite a lot of tools that are useful, lots of editors and IDEs, etc. But when we go into that, I'm going to jump into, from sort of the easiest to the hardest parts of Python. One piece here is list contexts. How many people are really familiar and happy with list context? This is sort of at the beginning level here. What?
List comprehension.
You're sorry. I keep calling them list context. Right. List comprehensions. These are just nice ways. It's just a really slick little idiom. This is the type of stuff that makes Python so fun. It's stuff that you used to have to code that was long. It's concise. It's just a cool way of doing it. After a while, you think every language should have this. After another 6 weeks in a point release, every language does have this. And you start saying, this is what you use. It gets rid of things like map, filter, and reduce, so you just don't have to use them much. And yes, obviate means make obsolete. So it enables you to make things that are short and readable so that your eyes will stay on the screen and can keep more of the code in your head. And here's something that's true almost all the way through Python. You see a fancy language feature. And all it's really doing is unrolling your syntax into something that's a bit longer, but still very simple. In this case, and I hope everybody can see the code, we've got one line up here. We say, sum all of the elements of this list, where the elements are billed minus paid for the various customers that match this function call. On a regular editor screen, this will fit happily within a 72-character line. If you had to code it without list comprehensions, you're probably looking at 5 or 6 lines of code. And then you probably want to put a blank line before and after it to show that you're doing something in one spot. And pretty soon, you've got one of these routines that sort of scrolls through 15 screenfuls of code to do something fairly simple. And at that point, you might as well go back and program in Java. When I was at JavaSoft, we designed it to be really, really simple for people who didn't know how to program. So this is one of those things. It's simple. Python can look complicated at first because you see this top line and you're not quite clear how it unrolls out into something simpler. One of the other places that often looks complicated in Python, and we're going to jump ahead to something a little more complicated, is when you execute modules. You hit that import statement. And very similarly, you hit that class statement. And your namespace changes, and it can be kind of confusing, especially at first. But it's actually one of those spots that once you get it, it makes Python simpler and simpler as you go. Imports run code once. When you hit a class definition, it runs that code once. The def, the keyword that makes a new function, is just another statement. And what it does is it compiles up some code, and it attaches that name and that code and sticks it in your local namespace, which is just a dictionary that your namespace may change. Inside a class, it has its own namespace. Inside a module, it has its own namespace. Inside a method, it has its own namespace. And almost all of these tricks in Python come down to just going through and manipulating those namespaces and running those scripts from top to bottom. In this case, I'm going to show you a quick trick that people use for if you've got to do a bunch of fancy setup on a module, that it becomes useful to just make a helper function to do it. So here I've got a class C. Just like a module, it changes its namespace after it's all done. And we're going to come back to Metaclasses in a moment. First line there, print hello from C. It's just going to execute this code from top to bottom. So on the console, it'll print out hello from C when it sees this code. It's just running it. This is actually really useful for trying to figure out what's going on, is to just put a few print statements in your modules in the midst of things and see when things run. It's not inside a DEF. It's not being compiled. It'll just be executed. So first it executes hello from C. Then it sees a def make this function. It compiles that function up, takes the name, help make table, throws it in your local namespace, and you've got a function with that local namespace. Notice that even though I'm in a class, it's not taking a class argument. I now call, I set a variable equal to something using that. Well, it's in my namespace, I can call it. CTable becomes in the class namespace. It's a class attribute at this point. And then I just delete that table out, and it's gone forever. I'm just playing with that namespace. All I'm doing is running from the top to the bottom and playing with the namespaces. This will be a little hard in Python, because so many of the buzzwords and things that you do in Python are just playing with this particular fact. It's a very simple language under the hood. Now we're going to jump ahead. You know, normally people would sit down and they'd cover this in great depth, and then they'd cover a little piece more and a little piece more. We're sort of jumping around a little bit. These are the decorators. They came out in Python 2.4, 2.5. And they're cute. They have nice syntax. They use the @ sign. They wrap methods with a new functionality. So the place that you use these is for logging, security, debugging, places where you want to have all of that original functionality, and then you want to do something that's kind of really different to it. Like, for example, you might wrap a routine and say, I want you to trace every time that you come through this and print a message on the screen so I can track what's going on with my program. You might wrap it and say, look, this is an edit page routine, and it's all about how do I edit this page. And right up at the front, I want to decorate it and say, I really want you to check the security level and make sure that the person has the right permissions before I let them edit this page. And so what it's doing is the decorator itself is another routine that's going to be called. That routine will probably call the decorated routine. The easiest way to see this is in the actual usage. It's got a very clean syntax for use, and it unrolls like everything to simple code. What actually happens here is that when you decorate something, you know, first I'm going to show you this, and then I'm going to tell you what that bottom line does. So first, we could talk about, you know, decorators actually return functions that are functions that take arguments that call other functions. Ignore the syntax that comes out of the box. You go out and you get the one from IBM, the decorator class, and you import it. And then you have something that turns any function into a decorator. So this top function here does a trace. It takes a function. It takes a bunch of arguments. It takes some keyword arguments, which you want to print out a little bit differently. And it prints out that it got called. And then it will actually call that function. One of the things you'll notice here is that in Python, just like in the previous example, the name of that function is just another name. So I can pass it f as a function name, as a function. And that's sort of the attached to where that function code actually is. And then I can call it later. So all I'm going to do is I'm going to print something out, and then I'm going to call that function. And since I'm about to return anyway, I just return that return value of whatever came out of it. So I can wrap any piece of code in this, and it'll call it. The decorator in there does a little bit of magic to make sure that the function names don't get messed up and things like that. And then down here is how I use it. I put that @ sign trace, and then I go off and I define my buggy function someplace to go do all of its normal stuff. What's happening behind the scenes is it's unrolling this code, this @ sign trace buggy function. After you've finished the def, you've compiled up that code and assigned it to this name buggy function. What it says is, well, what I really want you to do is say trace parenthesis buggy function with all of its arguments, and assign that to the name buggy function and call that instead every time. So it says buggy function equals trace of buggy function. The decorator class, the decorator at the top wraps it all up for you nicely. You'll use this in places where what you don't want to do is have you don't want your module having to do two separate things that don't make sense together. Editing pages and checking security levels. You don't want it to have to go out and crowd things up with timing routines when you just want to say, I've got a little function that counts up how much time I spend in this routine, and it's a poor man's profiler, and so I just say, time it, and I run it a few times, then I take it back out. This is a very clean syntax, and it's one of the cool things in Python that a lot of people won't learn about. So these have been very cool things in Python. I'm really excited about them, and they're very slick, and it gets easier as time goes by. This decorator, this @decorator class didn't exist yet. It's not in the standard library yet. You just download it and import it like everything else. And there's some dark sides to Java that aren't so clean. The first one is metaclasses. You'll see these occasionally. This is kind of towards the end of where people are skipping, so I'm sort of skipping towards one end of what's going on in Python. And this will be a great interview questions. People will always love to ask you about metaclasses, and then they won't use them. What they do is they put a false front in front of your classes. When you declare a class, you might want to go in and play with those class definitions, the names of those functions, or who the parent class is, before anybody uses them. Places you might want to do this include if you're writing some program that's going to be doing some mapping out to IDL or out to an object relational database mapper or something like that. So this is a buzzword. This is kind of, most people won't use metaclasses. Right now, you're probably expecting me to say, oh yeah, now it's two @ just before your class definition, because that would make so much sense. And just say, two @ call this function. Well, this is the bad side of Python. They haven't figured that out yet. What they have instead is it's implemented that classes themselves have a type superclass. And you can have all sorts of fun arguing about what your terms mean and drawing funny graphs, or trying to decide what happens to things that have multiple inheritance from two different metaclasses, from two classes that each have different metaclasses, and what happens there. And the short answer of it is, because the syntax is so horrid, and because what you're doing is changing the functionality of Python, you're getting in the middle so that when you say class something, it's not doing quite what you expect. It's actually calling something else. What happens is it adds complexity to the entire project. This is not an individual programmer decision to start using a metaclass. This should be a project or even company level decision as to whether you really need to do it. So if you're making something like you're making Plone and it's going to have this thing, or Django, and it's going to want to go through and map all of the attributes into some database, you may have to do something like this, but you should approach it carefully. And one of the sort of takeaways is that there are a bunch of shiny little hooks that people sort of talk about, and they like to talk about it, and they never really find good uses for it. And they're shiny, and you think, oh, I'm a great programmer, I should go start playing with these. And they can be traps. They can morph the language outside of what you're expecting. All of a sudden, if you're using metaclasses, especially if you end up using more than one metaclass in your application, your debugger might get confused. Your testing tools might get confused. Things won't happen quite the way you want. But you might need to look back at this sometime and decide that this is what you want to do. And there's some code for it. And the way you can tell that you're in a bad area of Python is this is boilerplate code. Almost anywhere you start seeing boilerplate code, you know that there'll be dragons here, because otherwise it would be clean and you wouldn't have to. So this is you declare some class that inherits from the special class type, and it overrides one of its new functions so that it can get a hold of just before the class is created, it runs this class, it runs the keyword class and runs all the scripts inside of it and bundles everything up that it got in there. And instead of just making a class object, it calls this routine, which then may go through the list of attributes, which are also the function names, and start doing something with them. It may need to wrap everyone in a decorator. It may need to, you can do some things like you can write an aspect-oriented programming system in this. But you're changing the functionality of Python. And if you do this, you really want to make sure you need to, or that you're just getting something cool out of it. And then some other class down here will specify that Metaclass is going to be used. Does anybody recognize what the name of the function means? They're going to change the syntax again for Python 3000. OK. So so now you know. Look, we just talked about some really cool aspects. List context. They will make your life faster and simpler from the first day you start using them. Decorators. You'll find that there are places that you use them, and they keep your code a lot simpler to understand because you say, this edits a page. You don't have to say, it checks security levels, and it edits a page. It just makes everything nice and simple. This stuff will probably make it more complicated. This is going to make it way more complicated. This is Unicode. This is one of those things that is coming. It lets you draw little airplane symbols in the middle of somebody's name by accident. Here's what we get. Unicode represents every human language. It represents all of the French characters with little accents and dots. It represents all of the Asian languages that may go up and down instead of left to right, or Hebrew that goes right to left, with a completely different set. It represents, what was the universal? Esperanto. It represents things that are used more than Esperanto, like Klingon and Elvish, 2 different types of Elvish. You can write anything in it. It breaks every single rule about ASCII.
Every major language.
They're working on the Babylonian cuneiforms. They haven't come out yet. But really, it's getting pretty close. You can bug me after class. I'm curious which one's not in there. So it breaks every ASCII rule you'd think of. You don't know how many bytes your characters are. When you read bytes from a file, the bytes don't tell you what characters there are. You just have to have adopted some convention to move from bytes to characters. You don't know how wide things are going to be. So you don't know if your labels are going to write over something else. And if something's on the screen, you don't know if those characters are the ones you think about or something in some other dictionary that are different. And so, 1 and L get confused. Well, everything gets confused in this. It's designed by a committee, an old-fashioned style committee. Please pay us $50,000 to join. And we're going to move what gets done when by how much your company paid and your current tactical goals. It's not an open source thing. This tells you Python has to deal with some of these real world constraints. So why don't we take a moment and cover some of the basic vocabulary that comes with Unicode and dealing with all the languages in the world and all the typefaces in the world and all the ways we write. And we're not going to do that. It's a whole area. You can specialize in Unicode for a long time and then decide something in Unicode to specialize in. Most developers just have to make some sort of armed truce with Unicode. You're going to find that because you have to use Unicode, your programs will be buggier. They will not work as often. It will be harder to write an application that is clean and slick. And that's just one of the things we have to deal with now. And you just have to make your best piece and learn, say, UTF-8 encoding. And try to remember that when you do a string encode, it'll throw you a Unicode decode error. And when you do a string decode, it'll throw you an encode error. And you'll just have to deal with the fact that as you try to use Unicode, it's not going to make your internationalization particularly easier to do, but it's going to cause you more bugs. And it becomes the standard string type, coming soon, to Python 3000 near you. Python 3000 is another one of those buzzwords people have been throwing around for quite some time. It means the next version of Python, Python 3.0. You know, it's got the beautiful picture here of the 3,000 golden Buddhas, and people were going to contemplate this for a long time and come out with something radically different, and it was okay to break all the code in the world. And fortunately, that hasn't happened. Everybody, you know, language about this size, everybody starts trumping out all of the things that broke in the last 7 languages that they wish were in there. And people start making all these proposals. And fortunately, most of them are ignored. So it's an incremental, not a revolutionary change to the language. There are going to be a few little syntax changes. You're going to have to learn to type print with parentheses around it because it's more consistent. You're going to have to need to read through all of the old code of that 1,000-line Python crufty program you have, go through it line by line to look for things that the little pi 2 to 3 conversion tool is not going to catch for you. Like, for example, chopping off the last character of longs and things like that. It's already available. Tuesday, there was another alpha release. Little pieces are being implemented. And you do find that Greedo exercises a large amount of restraint in what's happening to Python here. That said, I'm going to show you one of the features. And I'm working off of the PEP, not off of Tuesday's release here, the proposal as to what's changing. So one of the proposals was function annotations. That was going to let you go through and add little comments into your functionality so that you can describe what every parameter does. This sounds like a nice idea. So you can go through and you can say map X, and you can put the comments in here in blue, or the little string comments that tell you what each parameter means and what the return type means. That's great. Like every new feature that's coming in, there's going to be sort of a hard period, because it turns out you can also put in any other random expression. And some tools are going to want to use this for type checking. Some tools are going to want to use it for documentation. Some tools, they don't know what they want to do, but they've always wanted this in the language. So when you start using somebody's library, you kind of have to figure out what they did, and it takes all the fun out of programming to play with this stuff. But it's coming, and it'll work its way out in a version or two. And that's the end of the sort of the dark side. So you have some really cool things, and you have some things that are a little hairy. Python 3000, Unicode, and Metaclasses are all a little hairy, even though they should be cleaner in time. Right now, they aren't. But you go to the libraries, and you find there are so many people working in Python that there are libraries for every standard endeavor that you want to play with. So that if you're a startup and you're saying, I want to go off and do this thing, except for that very special aspect that you're bringing, there's a library that you can contribute to or just use that will get you most of the way there, so you can spend all of your time on that special thing that you're doing. Now, I'm not going to cover the ones in the standard library. I'm going to cover things like the PIL, the Python imaging library. Python imaging library reads and writes image formats. Lots of them, 250 of them. It seamlessly deals with JPEGs and PNGs and Windows bitmaps and all of these different types of formats. It's clean and it's slick, and it lets you just sit there on the command line and play with it until you figure out what it is you want it to do with that image, and then sort of cut and paste it into your program to use it for later. Now, one of the things is this is a very standard thing that a lot of people need to use. It's a very solid library. It gets updated once a year, whether it needs it or not. Like on the anniversary, they just sort of say, 1.18, 1.19. They tell you long in advance. There are no bug fixes in it. They just want to make sure you know that it's still alive. Python has this battery included model, but not all the batteries are included. There are things like PIL, which is a very rock solid piece that you'll find that everybody eventually learns about. So let's take another look at a rock solid library. Oh, sorry, here's how you use the PIL. I'll let you just read the code. It lets you load in images, resize them, write them out as different types of images in different formats, play with the RGB values, the transparency values if the format handles it, all sorts of, just about everything you want, put together GIF animations, things like that. And it just works. It works well enough that you're usually not bothering to look in the manual. You know, it's got a manual, it's got a one-page, this is how you use the library tutorial. And you rarely look at the manual. So here's another rock-solid library. Anybody guess what it does? It's friendly, it bites you. This is Pygame. It's really popular for a lot of people. If you're learning Python and you wanted to start by making games, a fair number of people learn a new programming language by coding up their favorite games in it. You probably start with Pygame. It's an easy 2D game engine. People teach with it, sometimes in high schools. There's a lot of it's an aggressively cross-platform because the first thing people do when they get Linux running on some system, like I have a little GP2X battery-controlled gaming system that runs Linux, they get Python on it, then they get Pygame on it, and then they start, you know, playing around with games on it. So it's easy to use, aggressively cross-platform. They do things like contests where people show up and they can say, OK, within a week in 48 hours, let's all build games and see who gets the best game in 48 hours. And when you arrive, we'll tell you the magic 3 secret keywords. You have to have hopping bunnies with flamethrowers. You know, go make me a game about hopping bunnies with flamethrowers. And people will. And thousands and thousands of people work with this thing. And it's done. They haven't released a new version of this software in years. As an old programmer, this is strange to me. This is done. It's finished. They argue it once in a while, but maybe they should add something. And then they end up saying, no, you know, we'd rather not. This is a nice static library. But it's not really static because there's so many people using it and new ideas floating around and ways to interface it. And it comes up with all sorts of games like these. You know, you can make pretty games out of them. You can make all your splash screens and your moving things and your game logic and different people inputting on different consoles, moving different types of sprites around. If you pick your graphics right, it can look kind of 3D. It's not really, but it can look kind of like a 3D game. And it's a great way for people to play with Python.
OpenGL plugs into Pygame, so that very well might be 3D.
Pygame itself aggressively is not 3D, but there are ways to poke with it and that are well documented saying you really want it to be 3D. We can do that. But if anything, Pygame actually tries to keep you from doing it. It's a good point. You can do it. And a lot of people actually do that with Ogre back and forth, although I'm not sure. So this is a solid library. Now let's look at one that's not solid. If I go in and say, oh, this is a great 2D game engine. Python 3D game engine, hit Google, I'll get Soya. Soya claims to be a nice 3D game engine, almost. It's had 2, maybe 3 games written in it. Development was so slow, they forked it off to another open source project called PySoy. And just for the extra buzzword, it uses Pyrex all throughout in order to try to speed things up and link to other libraries. There's about 4 or 5 ways of linking to C++ code. Pyrex is one of them. It tends to take a little bit more programming to keep up with everybody else's releases. And you know, we could have a whole section on how do you link to C++ code. Pyrex versus Py++ versus C types versus all the other choices. But it's slow. The development was slow. The execution was slow. If you just have this Python-centric bias saying everything's got to be written mostly in Python, it's not going to work quite nearly as well as something like Ogre. Ogre is a large C++ engine. It does scene rendering. It does it very well. When you want to put together something where you've got like a skeleton moving across a plane, and there's shadows, and there's fog, and there's some lighting effects, and there's 52 objects put together. You go off and you use Ogre. Commercial programs have been written in Ogre and shipped and done reasonably well. And also a lot of people use Ogre where they're still deciding whether they're getting funding for their 3D gaming system. So somebody made Python Ogre. First, it was just a set of bindings to Ogre. Then they started using Py++, which is another way to convert with C++, except that it's really fast in terms of your programmer time. So it gives you an interface that you don't tweak much, and that means when somebody revs some other library, it just works. And it goes off of Ogre is really popular. On the C++ side, there are thousands and thousands of users of Ogre. But in order to make it work with Python, they just wrap it in Python bindings and say, now you've got a nice language to write your AI code in, and you've got a nice language to do your game logic in, and you have all this beautiful scene rendering. And then they start doing a mashup of a whole bunch of other libraries. So this is what's in Python Ogre. It's got rendering, including some tree stuff, and it's got IOs and GUIs and sound, and often there's one or two different choices because in games people say, oh, we need this little one for this tweak or whatever. And it's got physics and networking. And the important thing is all of these things that are written in blue are actually spin-offs where they're wrapping things from the C++ world. So even though Python is not nearly as large as the C++ world, especially in game development, they can surf off of all of the thought that these people have done to making nice interfaces, making these pieces play together, at least in the C++ world, so that when you call them in Python and they have to call each other, they do the right thing seamlessly. So sometimes you can make a really good set of mashups, and you can run across them. As you're looking for libraries, if there's a very popular library in another language, go and see if there's some Python wrappings that do it justice. Those are libraries. Yes?
Sort of the 3D thing. I haven't tried it myself yet, but I've heard a lot of good things about Panda 3D. Because Disney and then kind of
Spun off?
Spun off with Carnegie Mellon, and it's supposed to be easy to teach and easy to use.
There's a bunch of choices.
Just like a graphic template.
And as the slides and notes are going to go up tomorrow morning, and that actually has a link to some of these long comprehensive lists of what's available in Python graphics and which ones go with what. I'm just trying to sort of show, look, here's Ogre, it's pretty good. Here's Soya, it's not so good. Here's some solid things. You will use the Python imaging library if you need to do anything with images. There's just no reason not to. And you will use Pygame if you're just wanting to play around and kind of get things going. Now, I could have picked on all sorts of different sets of libraries here. I picked games because for a lot of people who are learning Python and getting into Python, that's a good place to start. But there's usually a sort of a set of 2 or 3 good libraries in any area. And you go and you find them. Now, there's some tools that will help you find them, and I'll talk at the end about how to pick among them. Eventually, these libraries kind of grow. Like here with Python Ogre, it used to just wrap Ogre 3D. Now it's wrapping Ogre 3D and mostly things that have kind of split off and are parts of this Ogre development system. But eventually, you make these frameworks. And today, I'm going to pick on web application servers as a set of frameworks. I'm going to review 4 or 5 web application servers, the most popular ones, and kind of tell you what to look for when you're picking a thing. Anybody recognize the cover? Anybody recognize this picture? Anybody? This is a cover from Phil and Alex's Guide to Web Publishing. Many years ago, they made web application servers before people called them that, and gave you a coffee table book to show you how to do it with lots of cute photographs of him and his dog. It's to deploy web applications, which means it runs on a server in your browser. It's a huge pile of parts. And mostly it's a pile of parts that have been put together with some amount of careful tweaking and some choices that have been made along the way. And there are dozens of choices. which means that if you sit down with your development team and say, which one should we use? Pretty soon you're going to be having fairly vicious religious arguments about the pluses and minuses of each one. And of course, the correct answer is, did you happen to hire two people who have both worked in the same one before? Yeah, use that one. If you're starting from scratch, these are all the pieces. Almost every web application server out there is all of these pieces. Or it tries to be, or it tells you to go off and write them yourself. It's a messy slide. That you've got some user identity and some Ajax bling on the front, and you've got a web server that rewrites the URLs so they look cute, and they do this, and they eventually call some piece of Python code, which may or may not be embedded in some page. And it renders a page out to you, and off it goes. And it has to work between Python, which is an object-oriented language, and really efficient databases, which generally aren't object-oriented. And then you can keep adding there's an admin interfaces and stuff. So when you look at something like Zope, here's Zope. It's an application server. It's been scalable since the dawn of internet time. It's got a full web-based admin interface so that people sort of can click in over the web and administer the web applications as they go and turn things on and off. And it is really scalable. It runs a reasonably sized website. You couldn't run Amazon off of it easily. But if you wanted to, say, run Macy's.com, that shouldn't be a problem. You want to run Macy's.com off of one, maybe two machines? It's a big framework. You could do that. Even during spiky holiday traffic, it's pretty efficient. It's got, if we go back to the pictures here, you've got a lot of things about how caching works. And it's gotten sort of a cadre of people, of the people who are working for hardcore websites are just making it work, and they don't really want to try to make it more user-friendly. It's kind of hard to pick up. You hire people who've worked in Zope for years. And it's successful for what it aimed at, which is medium to large websites being very efficient. It's not going to easily move to something that's just really beautiful for random users to pick up. And there's some other options for that. And when you look at, so what does Zope do? You go back to this picture and say, OK, well, what part does Zope do, really? And you start saying, oh, well, it's got its own little toy web server, but it actually will use Apache for when you want to deploy. But you can run with its little web server. And it's got its own URL rewriting system. And for the most part, because it was so early, all of these things, it writes itself. It writes its own security managers. It actually has its own Zope database, but it also talks to regular databases. So it has an object database built in. It's got a lot of stuff. If you go to something else that's really popular, you get something like Django. Competes with Zope. A lot easier for people to pick up and start running. It's very slick. It has an attitude that fits with Python in terms of being something that's concise, doesn't like boilerplate code, likes to go through and say, you can just sit there in an interactive console and type in code and things happen. That said, the biggest problem it has, it's unfortunate naming choices. First of all, it's Django, not the Django. You have to explain to everybody there's a silent D. And if you go into Google and you type Django, it will come back with a very famous musician and a very famous musical style, and possibly music schools. And eventually, it'll mention, oh, yeah, there's a popular web framework. But popular to us is in thousands and thousands of users, not in millions of people who listen to Django music. Also, they name things in ways that make it hard to describe to people. Instead of model view controllers, they call it model controller template or something like that. They make up their own terms. One takeaway from this, if you want to make a popular system at some point, confusion comes from bad names. If you pick bad names, people are going to be confused. That said, if you go back to your little list of this is everything, Django writes most of its pieces itself, kind of like Zope does. It is written more recently. It's written much more user-friendly. It takes advantage of things later in the language that weren't really available when Zope was written. And it faces competition from people who don't mess up the names, like TurboGears, which is, it's more assembled from parts. It's more friendly. It's got a lot more screencasts that go out and sort of like, OK, this is exactly what you do, and this is how you set up your basic website. You can buy our books. You can come to our seminars, and we'll teach you all about it for a nominal few $1,000s a day. And the outreach sort of makes people happy, and now it's considered a little bit of a toss-up. I'd still go with Django, but some people will go with TurboGears. And again, if you happen to get two people who started with one, that's fine. Most popular little book out there for Python application services carefully switches back and forth between them so that they can sell to two crowds. What they do is they patch things together. They take the same thing and they say, well, we need a little Tory web server, but somebody out there wrote Cherry Pie, because there's all these people writing stuff. So there's a little Cherry Pie web server out there. For the Ajax, well, there's MochaKit. Somebody wrote a whole bunch of little Ajax routines that do all the flashy, blingy things on your site so that you can scroll up things, and the way Gmail sort of updates everything. That's nice. For the object relational mapping, well, there's SQL object. We'll just go do that. Template engine, somebody made one of those. They write very little of their own code, so they can come out and work on really promoting it and trying to get people to think about the same way and try to hit that magic level of user use. And because, wow, there isn't really a leader in this, this means you get all sorts of people. These people are coming out and saying that they're the greatest thing. They've been around for a while, making 1 or 2 websites. This isn't even their logo. They have yet to decide what logo it is. But it's sort of, if I were going to say, who are the top 3 or 4 people being used, this would be number 4. It likes to re-implement a lot of Ruby on Rails. Rails is the package in Ruby that does the same type of thing and has all those same components. So it does lots of code generation, just like Ruby does. It's great. You can come down and you can say, OK, we sat down this afternoon. We started working on the project. We got 4 megs of code going. We all deserve raises. We're doing great here. By evening, we're going to have 12 megs of code written. It is flexibly assembled with a tool called Python Paste, which is specially made for creating yet more web application servers. It's so flexible, I can't tell you what's in it. It's kind of like if you had a conversation with it'd be sort of like, well, we use SQL Alchemy for our object relational mapping. I said, oh, I kind of like the other one. Oh, we use that too, no problem. What do you use for Ajax? I don't know. What do you got? MochaKit is fully integrated into it. Oh, but so is that other one you liked. And yeah, we use one of 15 different web servers. Just pick one. And this means that every installation will be different. But again, you can go to the boss and use all of his favorite ones. Flexibility has its limits. After a while, there are more of these than you want to look at. You want to go with one of the 3 standards. So go with Django, TurboGears, or if it's a big thing, Zope.
2 quick points. It's not MochaKit, it's MochiKit, and I know that because my boss was the guy who wrote it.
OK.
The second thing is TurboGears will soon be written on top of pylons, and so that's kind of like.
Yeah, the things eat their young. And it'll be written on top of pylons, probably. So, the thing that I think will happen is you'll find that there's certainly aspects in any of these where some of the code is just really well done. And especially if you go back and you look at TurboGears, they're already assembling from all sorts of different pieces. So working with a framework that's really just about assembling makes a lot of sense. One thing that's not really quite the same are content management systems. They often get really confused. They're slightly different. If you think about it, the web application servers are about how do I write something that's got all these funky applications on it and serves them. It serves Gmail. Content management servers are about the fact that you get these creative people and they come in, and yes, there's a place for everything, and they're in a hurry, and it never goes in the right place. And I don't know if any of you have kids. This happens all the time. So, oh yeah, we threw in some graphics files, and we've got to make it all work. And really, it was supposed to go through a spell checker before it went live to a million people and all of that. So these are built on top of web application servers. They're about website publishing. They're about people whose job it is to make that website fresh every day and put up new content. And you have a lot of things about flow of control, who has to edit, what's my workflow like. And you have things about what's my versioning like and how do I roll back and forth between different versions or show different versions to different audiences and test things. Now, they're built on top of web application servers. And so it gets a little confusing because people will go through and they'll write a little content management piece on top of it and say, oh yeah, now we're not just a web application server, but if you import this other stuff, we could actually be a content management server too. Fortunately, unlike the web application frameworks, where you're going off and you're picking between Django and TurboGears and Zope and pylons and all of these other things, you really only choose one. And it's great when some open source project gets there early and does the right thing. So you use Plone. You just don't, if you're going to have something where a lot of people are going to be editing the same stuff, and there might be a few people say, but we have one up and coming. Plone is written on top of Zope. It's got a strong support base. There are thousands of sites. If you go to the CIA homepage, it's Plone. If you go to a random university, it's probably Plone. Its biggest technical innovation was that it made a very strong support for new and different types of content coming out. So if suddenly you're serving a particular type of media, it can do that. If you're serving Flash games, it can do that right. It's not kind of something where you kind of hook it on. You just make it a first-class content type. And this means that again, these are all big areas where people can specialize in. And once you have the right design, you're going to end up with somebody running away with most of the market share, even though it's free, most of the market share, most of the mind share, and most of the new ideas flowing back in until it's far enough ahead that everybody who's hacking together websites says, well, I did something interesting. I could send it in and get it changed, and that way I won't have to maintain it every time there's a new release of something else. So this is just a random shot from one of the recent Plone conferences, and there are a lot of them. There are a lot of people who use Plone. So when you're looking for somebody to build something content management, you just say, oh, I need a Plone consultant. There are a lot of them. And a lot of these libraries grow into this set. So the frameworks, people have to specialize in using. The libraries are blocks that you can pick up and start playing with. And the frameworks are big problems that a lot of people have, so you build this big framework around it. Before you even get to the libraries, you're back to all of the different spots in the Python language, getting used to how to use its classes, getting used to use decorators, list contexts, iterators, generators. I think I'm kind of hitting that spot where I'm finished. Here's this big quilt of Python, and we've covered a few different spots here and there. And we say, look, there's little pieces of it here and there that we've talked about. But really, you just have to remember this is all about exploring as you go through. There's going to be more. And you keep exploring Python. You just have to play with it. When you're looking for modules, there is the cheese shop, which lists everything. There's CheeseRater, which tries to rate them and doesn't do that well a job. There's a couple of automated rating tools that sort of chug through. But Pygame hasn't been updated in a year or two, and every automated tool would say it's hopeless. Nobody uses it anymore. It's too popular. And the place to look is Wikipedia. Wikipedia will give you a good, fast rundown on almost every major Python module. And if it doesn't have a decent entry, it probably doesn't have enough users to make a decent entry.
You can add one yourself.
And you can add one yourself if you'd like to. Ignore the version numbers. Ignore the date it was last updated. Those aren't really going to help you as much as you think it would be. And you're just going to have to keep learning Python, because after you get past sort of the basic, here's this language and it's cool and it's fun to program in, what you're actually learning is all of the things everybody in the world is doing in programming that start showing up on your open source docket. That some of them are under GPL licenses, which can affect what you can do within your company. A lot of them are under BSD licenses that are just take them in and use them, and you don't even have to tell anyone. But you'll find that more and more, a lot of the problems were actually getting solved. We're getting big bulletproof libraries or frameworks that just do it. What used to be, we talk about these web application frameworks, and they all look sort of messy. But they solve problems that used to take a development team months to do, and now it's messy, and it might take you a couple of days to get something running. And somebody who really knows this tool might quote you 2 weeks to get your website up and running, 3 weeks if you want it to scale to 20 million users. That's it, Then you start saying, well, I've got this long list of features because everybody else has the basic stuff. And then you're back to using programmers again. So that's what I was talking about. It's some buzzwords. It's not all of them. It's trying to be a high signal to noise. I hope some of you will probably glaze over at some of this, but hopefully everybody got something out of it. My contact information, the slides and notes will be up tomorrow at charlesmerriam.com/talk. And the notes will include links to everything that you should be reading and playing with, and hopefully will become a reference in themselves. Thank you very much. Any questions?
So, to give another side of the pylons,
Not that there's a religious argument coming.
but yeah, I mean, for somebody just starting in web application development, it's probably not the easiest choice to get started with. But once you've written several web applications, you've been doing it for a few years, and you want to kind of know the nuts and bolts of what's going on, and not rely on like all this magic stuff going on behind the scenes. Being able to like swap one thing out where their choice didn't quite meet your needs. It's a lot easier for that sort of thing. And I really like it. I've written apps in all but Zope. So, yeah. I mean,
I agree.
yeah.
And I've written it in Zope and Clove and all of them.
So,
No, but OK. It is very, very flexible. I'll go with that.
well, it's flexible because it doesn't try to do, I mean, it doesn't really do a lot with JavaScript. It's kind of like pulling out some of the things. It's meant to be like a little bit, not quite as much of a framework as some of the others. Which is why like TurboGears is going to be kind of built on top of pylons. So pylons will be like a little bit lower level just to get the basics, and then TurboGears will be providing a little bit more glue and magic stuff on top of that to make it a little bit easier to get started. So,
And it would be excellent if both sets of developers ended up sort of adopting the same code that they were working on, because eventually.
yeah, the TurboGears 2 stuff, a lot of the internals have been ripped out, and it's just using the pylons.
Right. And you can see that what happened with Plone, in part because it started so early and it started on top of the Zope base, is that as things consolidated well, it's this idea flow that really makes things mature quickly, to the point that sometimes they're finished. OK, same person.
Sorry, Clone's not immortal either. There's Grok is apparently growing in popularity as another thing built on Zope, attacking the Clone code base or whatever.
That is the ecosystem. We'll see, and I think there's going to be a does this fish get big enough issue, because we have 2 engineers who are going to have 7 opinions. That's the way of it. No, I agree. I am not trying to sit down and advocate, oh, these are the strong opinions about it. I'd be truly surprised if people jumped up and said, oh, there's another one that for a web application framework dwarfs these others. if you started anywhere with any one of these, you would probably find that you could go back and start doing something else well. One of the oddest things that you'll also find that is, if you're an engineer, you may well want to carefully look at it and decide that you're going to spend your entire career worrying about a better template engine, worrying about a better Ajax library. And there's some good talks on how to do good JavaScript libraries, and it's not always obvious. Or you can spend all of your time writing that Python code, which is a good thing to do. Database specialists have always been around. We're solving very large problems. Each piece that you put together is often very tricky.
You know, on this subject,
Okay.
not mean to add arguments, but I had an application to build. It was a web application. I hadn't done any web apps. I was familiar with most of these frameworks that you mentioned. Familiar that I've heard of them.
Mm-hmm.
And I started trying to use Plone because I thought that would be, it had a lot of the components that I wanted. It had all the administrative controls and things. But I wanted to actually, I'm a Python programmer, and I wanted to write my code. And I found it very difficult to get down to the application. And I tried to use the archetypes. And to do that, I had to have this UML generator tool. I gave up. I couldn't get them, so I took a look at TurboGears and I bought the book. I started trying to build this same application using TurboGears, and I was struggling with that, found that difficult because it took you down this path and you had to do it in a certain way.
Yeah.
And I found pylons, and I found it easy. It was a simple app, simple to build. I didn't, you know, you had your choices of things. I liked SQL Alchemy. I could use the database that I wanted, which was not SQL Object, Firebird, blah, blah, blah. But I found it easier to use, and I liked you had choices of templating languages, and the one that was there was very Python. That they've changed since then.
Okay.
So that was my experience.
And so you'll find more people saying, pylons, it's very, very flexible. You can throw together all the pieces you want, and they like it that way. And it's really kind of hard, because if you go down using the wrong tools for a while, the tools all come with their sets of expectations. For example, if you're using Ply, which is a lexical analyzer for making your own grammars, it expects that you can just pass everything in memory. And it doesn't work if you can't do it that way. If you're using Py++ to interface to C++ code, it has certain expectations, and you may want to be doing something different. So there's always going to be a spot where just because you're head down in a project doesn't mean that you should stop exploring what other alternative libraries there are. Because you may find one that sort of comes up with the right set of assumptions for the problem that you're doing. And these assumptions are very hard to tease out. And people don't write chapter 1. This program assumes that you will use what we tell you to do because you just want your job done. Or in Plone, we assume you're putting up a public website, probably like most other public websites, with maybe 1 or 2 different things, and that it's primarily about managing content, which is why you're using us, and not about writing an application. People don't write these things down well. You know, if you're using the PIL, the Python imaging library, you know, it assumes that you're going to be using one of the formats that it supports. If you're picking something like, I know it doesn't support the Adobe Photoshop format at all. And it'll have an appendix that kind of says you could write your own support, but you really can't. You know, you just say if you're going to have to parse up those files, go write your own program. It's not going to work. So I'm not trying to pick hard on pylons. I know it's gaining in popularity. It is a little bit of an assemble it yourself kit, and sometimes that's what you want.
I'm using a Python for the mobile devices. Do you know what's going on? I know the first book is coming out this month, actually.
Mm-hmm.
But
You might look at Pyrex embedded as one of the things that I always found about phones is that you have a lot more deep constraints than you would expect. Your memory is often very constrained, and that they're constantly worried that you will do something that will eliminate its ability to make and receive phone calls. So you'll end up doing a lot more linking to C++ libraries to get things done. And I haven't seen outside of, the phone API world just changed radically. Google introduced theirs, which called Android or something like that.
Well, that's what I'm asking, because Guido works for Google, right?
Right.
Guido said that he is very interested in using in Python on the mobile devices as the future of the Python. And Google just announced the Android. So if you put all these three things together, it just makes sense. We'll see Python on Android.
Yeah, well, notice that there's a big change, and this is going a little bit off topic for the pure Python play. There's a very large change just in the last 2 months. Google announced its system where they're making a bet that people are going to want to basically brand their phones off of the services that the phone provides, meaning Google. Apple opened up their API, and they're making a bet that you're going to...
They said they were going to release a development kit sometime in Q1.
Okay, they meant to open it up. It didn't work, but they've basically made announcements where they're saying, okay, you're going to be going with the phone manufacturer, and that's how you're going to think of which phone you have. Sun has come back and came out with their set that says you can make it proprietary to your phone hardware. Go ahead, just license it from us. And so they just opened up something. You're going to see a lot of chaos in the phone applications world. Mostly it's all about whether I can write a little piece of application that can cleanly load and unload itself and share its resources in a friendly manner with the other applications running. That's all I can tell you right now. Look at Pyrex embedded as a new piece.
So Palm, I found it course runs on Palm, so any Palm-based phone. It also runs on Namespaces that he had on his phone. There was a guy, you have it running on your iPhone, and then like if all hell, like if nothing else works, you can always run Python under Java to get it running on Android. If nothing else is possible, that's still possible.
Well, I'm just wondering if there'll be some kind of basic configuration that you can use it from one device and just export it. Because UI issues, that things work right. It's what sounds like they gave to the meeting. Basically, this is the specs for whatever mobile device. Just wondering with something like this for the Python, because obviously you wouldn't have all these the image libraries and other libraries for mobile Python.
When I was at Sun working with J2ME, we went through a lot of iterations. And we used to call it J2 embedded and things like that. And we were selling people slides for a lot of money. And eventually people came to a conclusion on it. But it takes a while for these things to... It's a trickier problem than it first appears. Because when you're actually writing an application, it just works.
When I went to market TechTalks a month ago, and they showed them a lab of Python, they're very excited about Python because the learning curve for the C++ environment is kind of hard for them, which has to be completely different. So they're actually pushing it hard. I mean, they're very excited about this book about mobile Python. It's called Mobile Python Prototyping, something like this.
Mm-hmm.
So they're very excited. But when I went to the session, I haven't seen the reason to use it versus like use C++, basically, because I haven't really seen the motivation. Why should I use Python on certain on Series 16?
I can give you a reason on the item.
Well, that's why they're happy about the Python. That's why they put Python on Series 16. But it's, I think it's not practical. The prototyping is fine. That's why a book is called prototyping. I think you will be developing the real applications in Python. If you can answer the question.
I'm sorry, what is the final question here?
No, just a comment.
Okay. Yeah, no, it sounds like what you're saying is it'd be nice to have either a chat group or a meeting on programming for mobile phones. And my guess is that if you did it right now, you'd probably get a lot of hints, but nobody has answers yet. Yes?
So I've never programmed Python, so take my comments with if anything, your presentation somewhat scared me away from Python.
No, that's legit.
And let me explain why. Is that there were three kind of points that you brought up, which I kind of latched onto. One is there's gonna be a new version of Python, and I have to look through every line of my code to make sure it's compatible. Okay, that's one thing. The second thing is going from, I've gone from procedural programming, Fortran, C, to object-oriented with C++ and Java, and now I'm looking at more dynamic object-oriented languages, such things as JavaScript and Python, these things. And so the dynamic aspect of the language is an interesting thing. From what I'm hearing from here is that metaclasses is the way to achieve the dynamic part of this language.
Okay.
Let me finish.
Yeah, no, that's what you're hearing. Go on.
Let me finish comment. Is that, but you haven't given me anything else to make me believe there's any other way to do it than that. The third thing is that yes, I agree, Unicode is a messy thing, but it's canonical. Like if you say, here's a sequence of bytes that should define this character, there is a clean mapping it should do. Now, if I'm assuming from what you're saying, what is that Python isn't giving you a clean way to do it, so your results are messy.
No, that's not true.
But I'm just saying that's the impression I get from this presentation.
Okay, those are valid, and I'll look at each of those. And first, I appreciate people who get up and say, this didn't sound good. What we've got here is, this is not the rah-rah Python is great speech. There's enough as you go through just the regular Python tutorial, you'll see how much stuff. And look, I was at JavaSoft. We made a language that is so hard typed. Well, it turns out people don't make typing errors anymore, and dynamic languages really are really nice. And if you look at some of the languages, Python's an interesting trade-off. Ruby gets all the Lisp programmers. Ruby and Lisp go well together. And JavaScript is great as long as you're ready just for what JavaScript is good at. And that's okay. Whenever, even in Java, if you open up a file, you have to tell it which encoding you're using. Usually you're going to be using UTF-8, which is great for American languages because your standard ASCII will come out in 1 byte, and not so good for some foreign languages because your standard random kanji character is going to come out in 8 bytes. But the stream itself doesn't tell you which encoding it is in. And some people will use UTF-16 or 32. Some people will use some of the other encodings out there. Some people will use different choices as to which code pages to map the same characters on. This is not a Python-specific problem. This is a Unicode problem. And the case that you're going to get is that all of the stuff that you can control is going to work fine. The things that are going to hurt are that you're going to have to write some new test cases to say, when I ask the person yes or no, and they start putting in one of the 2 different ways of putting Korean characters in. And some of the pieces don't break nicely in the way that you'd like. And on these weekly conference calls, they argue about this. Is this going to break my code, or is this going to put my kanji characters right over the critical piece of data so that the person, whenever he tries to click OK, is actually selecting their kanji characters? This is going to be true in any language. And it's almost unfortunate that there's not a big welling and saying, oh, we'll make an open source alternative to the Unicode problem. But it's not likely to happen.
But it sounds like there's 2 things you're saying about Unicode. One is the encoding is not defined in the stream itself. And the second is the layout for some of these things are dependent on the rendering engine used to lay it out. And to me, that's 2 different issues. But to address
yes.
The secondary issue I don't really care about. I know it's a valid issue.
Python will provide you as okay.
Itself, because it's standardizing what characters are what. But the first issue of what's in the stream, well, if I opened up a file that's written with Epsidic versus ASCII, I don't know. If I open up a file that's little endian versus big endian, I don't know. It's just a definition. That's all it is. So as a definition, I think Unicode is fine. Sure, maybe it's bloated and overdone and all that stuff, but it's fine. It's just if there's not a good library or interface to access and manipulate it, that's where it falls down. But I think your slides do a disservice to Unicode, where it's really how you interact with Unicode.
I think we'll probably just have to agree to disagree on this matter of how clean Unicode is. Yes?
So let me answer your question, if you don't mind. Unicode's hard. Internationalization is hard. That's constant. As far as Python specifically, Python has built-in Unicode type. Ruby doesn't. PHP doesn't. Java does. Like, if you know how to do internationalization, Python is awesome. If you don't know how to do internationalization, Python will not rescue you. That's all.
Yeah, and I think one of the things that is coming to people is that as Python goes to the next version, Unicode becomes the default string type everywhere. When you say, quote, hello, it encodes that into Unicode according to some rules. Usually it's UTF-8 unless you've set something else.
Can you address this comment about metaclasses?
Right, metaclasses, as I said, they tend to be the interface. You don't go there. Metaclasses are for when you're changing the behavior and doing things that you really just can't do in Java. And you can play with it even more in Ruby, but it becomes very opaque. And what it does is it's allowing you to change certain behaviors. The classic examples for this are when you're going through and you're saying, when anybody defines a class in this area, then I want to go through and play with all of the instance variables for those classes so that I can create an IDL mapping or so that I can create an IDL mapping and talk to some old Cobra server over there, Corba server over there, and or I want to put it into this mapping where I can then go out and I can talk to some object relational mapper and never have the person ever have to specify anything. I mean, I've looked through a lot of Java code where half of the code is written about swizzling it into some particular XML format and back out. And you shouldn't have to do that.
But I guess
Metaclasses are not something, what?
More specifically, I was asking about, is metaclasses the mechanism that adds the dynamic in Python being a dynamic?
No. No. And the way that Python actually handles that dynamic is everything is running that script and looking at a dictionary. And when you come down and you look at the dictionary and you say, OK, I want you to go off and draw yourself on the screen. Draw. It's not actually like in C++ where it's got a vtable, or even in Java it has about the equivalent of a vtable that's compiled in. What it does is it looks at that dictionary and says, for this type in front of me right now, does it actually have the ability, does it have a routine to go off and draw itself in itself or one of its superclasses? If it does, then I can just process that. And I don't have to worry too much about the type, because it turns out that developers, after they have learned at least one statically typed language some point in their career, usually in their first computer science class, stop making type errors. Also, Python has a lot of unit testing built in. People actually do write their unit tests to try to cover this stuff. We find that this is not a problem. People don't make that error, the type error that everybody's worried about when they start talking about dynamic languages. The Python, it's inherent in the way that Python does a message dispatch.
I understand that, but if I have an existing class built by somebody else, I can only at runtime add some characteristics to that class.
You'd subclass it. You'd probably just subclass it.
But that's not using the dynamic part of the language. That's
Sure it is.
That's just inheritance.
Sorry, you can monkey patch any class if you want to. It's possible to do that.
But is that using this metaclass?
No.
Okay.
No. It's really using the fact that everything in Python is a list or dictionary. So if you want to change your parent class, you have a list of parent classes. You could swap in new parent classes. If you want to add a method on the fly, the class is a dictionary. Add new methods. So it's really, you play with the runtime engine basically.
Metaclasses is a fairly esoteric feature that's recently been added to the language that a lot of people, including myself, have never touched and probably never will need to. So I think it was just brought out that it's something there. It's very powerful, but it's pretty rare.
It's
Ju-
a
just-
buzzword.
It's a
But it's a
buzzword, yeah, it's a
buzzword,
buzzword, and it has, from a beginner's, from your point of view, what you want, Python is dynamic, and will let you do a tremendous amount of things in a dynamic fashion, and you don't need to worry about that.
Now, you want my Python language comparison talk, which is a different talk. So, okay. And feel free to bug me afterwards, and I'll answer any other questions.
There were a few other talks where they had sort of basic batting to quilts, and this is more like the more decorative patches.
Yeah, there's a quilt. These are like 3 or 4 random spots around it. Yes?
Boy, you still have that slide up. Are there any Python web application frameworks that handle migrations like Rails does?
Oh, I got that. Sorry. I'm sorry. Like, I wanted Rails migration, so I ported it directly, and it's on my blog. So you want to see afterwards? So the exact thing. Oh, okay.
Yeah. No, I think Ruby on Rails, for those that don't know about it, Ruby on Rails was great because they came out with like 2 or 3 ideas that people hadn't really been using enough of. One of which is, they said, your web framework application should manage your database schema and all of your database pieces and have a fast way of just saying, make me a new database that's up to date and migrate back and forth between versions of my database. Now, granted, it has some problems because it's very hard to test whether your down migrations actually do what you thought it would. But you'd be surprised how many people got burned that one day the database died and nobody knew that at one point somebody went into a MySQL console and manually created some index, and it just worked faster from ever onward, and it was never entered into anything that was repeatable. The other thing that Rails did very well was that they took an approach where they said that you should not have to configure things. You should work on a convention more than you should work on a configuration. It can actually hurt you a lot in Rails if you try to break the conventions, because other parts of the program that you didn't expect will want that convention to be true. If you have a database named people, there should be an object named person. You should not name that object anything else, or things will start being hard to deal with. But also, you never have to explain that there's this person and this people, and if I do a person dot find by last name, that probably means that there's a field in there called last name. It will just follow the convention to find it, and that's something that really came out of Rails as well. So you'll find that those things migrate around. One of the nice things is that in the dynamic languages that are fundamentally all open source languages right now, they latch on to really good ideas that other developers had and patch them in fairly quickly. And it can be, once somebody has shown you that this can work and has decided that this is a really good idea, it's actually not that much effort to implement it. Any other questions? Great, thank you.